right, here we want to graph this quadratic equation. We have y equals x squared plus 4x minus 5. In this equation, it's a quadratic, so I'm just going to quickly note what a, b, and c are because I want to be in the habit of doing that. And here a is an invisible 1. B is 4. And c is negative 5. So, armed with that knowledge, I'm going to try to graph this parabola. I'm going to try to get 3 points that are on this parabola, so that way I can define this parabola. So I'm just going to put spots for my 3 points, because I know that's what I'm going to end up needing. Okay, our first point we are going to find when x is 0. And this point is actually pretty much written for us in the equation. When x is 0, that is known as our y-intercept. So in our parabola, our y-intercept is always going to be c. So my first point is going to be 0, negative 5. And I can see that that's the case because if I take my equation, y equals 1x squared plus 4x plus negative 5, and I substitute 0 for x, then these two terms are going to both go to 0. 0 squared is just going to give me 0, plus 4 times 0 is 0, plus negative 5. And I'm going to be left with y equals negative 5. So my first point is going to be 0, comma, negative 5. C right here, my last term, will always be my y-intercept. So I can just put a point on negative 5. Now I can graph the rest of these points in a variety of ways, but I think this most simple way is just by substituting x values and seeing what I get for y. For this next point, I think it would be pretty easy to substitute a 1 in for x and see what I get. So I'll write my original. And then I'm going to take out all the x's. And I'm going to put in my 1 for my x's. Then 1 times 1 times 1 times 4 times 1 plus negative 5. And 1 times 1 times 1 is just going to give me 1 plus 4 times 1 is 4 plus negative 5. 1 plus 4 is going to be 5 plus negative 5 is 0. So here when x is 1, y is equal to 0. That's my second point I will plot on here. 1, comma, 0. All right, third point. I could pick a lot of different points. I'll pick, I guess I'll pick negative 1 for my third point, but I could have picked whatever I wanted. I could have picked 2. I could have picked negative 2. I could have picked, oops, I said I was going to pick negative 1. I could have picked whatever I wanted as long as it produced an x value that would be on this coordinate, or that it produced a y value that was on this coordinate plane. So y equals 1x squared plus 4x plus negative 5. And I'm going to take out my x's. And I'm going to replace those x's with negative 1. All right, and this is going to come out 1 times negative 1 is negative 1 times negative 1 is positive 1. Plus 4 times negative 1 is negative 4 plus negative 5. And negative 4 plus 1 is negative 3 plus negative 5 is negative 8. So right there, when x is negative 1, y equals negative 8. So here's my negative 1, Negative 8 is down there. So that's my third point. And those should be the points that define my parabola. So I'm going to graph this now. I'm going to go into con, and I'm going to just drag these points from where they are to here. Sure, keep. So going over to con. And my first point I said was 0, negative 5, my y-intercept, my c at negative 5. So I'm going to just drag one of my points over to the negative 5. Not caring too much what it does to my parabola as I move these points around. It'll look right in the end after I've graphed them all. My second point I said was 1, 0. And my third point is negative 1, negative 8. All right, and that should be my parabola. And I can see here that my I have a vertex at negative 2, negative 9, and I can see if I took negative b, negative 4, over 2a, over 2, I would get negative 2 as my axis of symmetry, which I have, so that's a pretty good check. The first thing I'm going to do with this problem is write down A, B, and C. A, B, C. In this problem, A is 1, B is 2, C is negative 6. C is my y-intercept, so I'm going to put my first point at 0, negative 6. Now I'm going to find 2 more points. And I'm going to do that by just picking an x value and substituting it into the equation. So I'm going to do first, let's do 1, because that's pretty easy. So I'm going to write my equation over here. Y equals x squared plus 2x plus negative 6. And then I'm just going to take out the x's. And I'm going to see what happens when x is 1. What does y become? One times 1 is 1. 2 times 1 is 2, plus negative 6. 1 plus 2 is 3. 3 plus negative 6 is negative 3. So when x is 1, y is negative 3. 1, negative 3 is where another point on this parabola will go. And for my last point, I'm going to choose the number 2, but I could choose negative 1, I could choose negative 2, I could choose whatever I wanted. And let's see, when x is 2, what is y? So I have y equals 2 squared plus 2 times 2 plus negative 6. Y equals 4 plus negative 6. Y equals 8 plus negative 6. Y equals 2. So when x is 2, y is also 2. 2, 2. All right, so those are my 3 points. Those are going to define this parabola for me. And I'm going to go ahead and plot those 3 points onto my graph in con. The first point that I'm plotting is my y-intercept, which is 0, negative 6. And it doesn't matter which of these points I drag to that. My second point I said was 1, negative 3. This point right there, that blue one. One, negative 3. And my third point is that green one, which is 2, 2. All right, and that should be my parabola.